Welcome to the first lab section of 688, Data Mining and Statistical Learning. So I'm going to try and break up the lectures to about 50, 60 minutes of some kind of theory, as we did today, and then 20, 30 minutes of some practical application. Because I think that having a mix of these two kind of skills is really important here. And so typically what we're going to do is we're going to talk about kind of how to apply some of the stuff that we learn in the lecture to real data. And our homework will not only have some theory problems, but have some real data problems. And we will also have problems on data camp. And I will send out an email kind of explaining some of these things. But for this lecture, what I want to do is I want to just do some introductory topics in R programming. So most of the work I'm going to be showing is going to be R programming. I don't really care if you want to use something else. Mostly I just care about the results. But the stuff I'm going to be showing is in R. I don't think people have gotten as much of that as maybe they've gotten Python. So again, we have our webpage here, and I will post the lab videos and the code here. And I'll have a link to that on our Blackboard page. So we're going to be doing programming in R. And I, in particular, like to use Jupyter Lab as a development environment for writing code. The other alternative is RStudio. So Jupyter Lab here is run out of my web browser. And I can write what are called notebooks. And notebooks are probably going to be the best way to do homework, which is you're going to have to write as a notebook and produce a PDF, either in Jupyter or in R Markdown. Notebooks are probably the best way for kind of displaying results and teaching results. So this is a Jupyter Lab notebook. I'll talk about RStudio a little bit at the end here, I can input commands here. I can input text. I can input commentary along with my code and plot output. So here's my session. I have my Lab1. IPYNB is the notebook format. Don't ask about that extension, but so let's start writing a notebook. So first of all, you can download Jupyter from Project Jupyter. So here's the link for that. So let's say we can write notebooks in. So here I'm writing in the chunk. I'm going to change it to, instead of having code be Markdown, i.e. some kind of rich text format. We can write notebooks in using a couple different IDEs, most popular being one, which is Jupyter, and I'll put the link here for Jupyter, which is a bit more advanced. So just advanced. Just being it's a little bit hard to set up for R. For writing Python, it's not as bad. So you'll have to install Anaconda, which is the Python backend to it, and requires installing Anaconda. Let's make that a link. So here, I'm writing in what's called Markdown, which is some kind of rich text format. So that's one option, and the second option is RStudio, which is obviously made for R. And so here's a website, rstudio.com. I'll put the link in here into my notebook there, and either can be used to write code in R, which is what we're going to be writing here. And I'm going to put the link for downloading R here if people haven't had that download. Okay. So this is the first kind of cell in my notebook. So I've written some text. I have some annotations, some links. If I run this, it renders it as what's called Markdown, so it renders it as text, and these links become kind of human readable. And so they'll take me, say, to my web pages. So I can put text in a notebook. I can also, if I hit add here to insert a cell below, I can, so you see how it says code here. By default, I'll put code. If I click here in this cell, it's Markdown. It's the rich text. I can put code, and so here I can put our code. And of course, the first thing in any programming language we want to type is hello world. And so if I type that and then I run the cell, hopefully it will work. Uh-oh. R is having some issues here. Now let's restart my kernel. And there we go. So just had a little restart there. And I get my output. So I have text, I have code, and then I have output. So R is kind of a nice high-level language. It's pretty easy to use, so it's not something awful like Python, or not Python. It's like Python. It's easy to use. It's not something awful like C or Fortran or something like that. You can use it kind of as a simple calculator. I can say 1 plus 1. That will give me 2. I can do 1 plus 2 times 5, right? That will give me 11, etc. There. So I can go back, I can insert, let's say insert a cell above here, and we can make it, let's say Markdown, and we'll say we can use R as a calculator. Some examples, and so maybe I want to insert a cell here. There are also some built-in constants in R. Let's make that Markdown. And for example, pi, if I want to get E, I can do exp for 1. So those are going to give me those constants. There are also special infinite values. So if I want to, if I do something stupid, like I say 1 divided by 0, I'll get infinity. Or I could do -1 divided by 0, and I would also get negative infinity. If I do 0 divided by 0, I'm going to get NaN for not a number. Other special values in R to denote nothing. We have, let's see, what do we have? We have null. So null is kind of no object. And to denote a missing value, we have NA. So NA is a missing value here, right? We can do kind of, well, let's say, variable assignment and simple objects. So if I put this hash before this, it should render it. Oh, if I render it not as code, if I render it as code, it's a comment. If I render it as Markdown, it gives me a big bold title. So I could say x is 1. That would assign x to 1. Using the equal sign, I can assign with this arrow. So I could say x less than dash, which kind of looks like an arrow. That would assign y to 2. I can do it this way, which is really bad. Form that would assign 3 to z. And I can print out the values x, y, and z just like that. Alternatively, I could do print x, and that would print x. If I want to look at vectors in R. Let's see, vectors in R. I can say I use the C operator, which stands for concatenate. So if we do x is equal to C1, 2, 3, that will give me a vector. Whoops. So let's print it out. That will give me the vector 1, 2, 3. If I want the second element, x2, that will give me 2. That's the second element here. First element is 1. If I were to change this, say to 5, 2, 3, 7, right? It would correspondingly change. So R is 1 index, so the first element is 1. If I do x0, that's gonna give me a problem. If I do -1, it's gonna give me everything but the first 2. So let me write that out there for you. So x is -1. So x1 gives me the first one. X -1 gives me the everything but the first one. If I do x and I pass it -1, whoops, -1 and -2, it will give me everything but the first and second. There are, what else can we do with this? We can make a vector out of anything we want, for example, right? So I can make a vector truths, which is from true and false values. So true in R is capital true, false is capital false, and I can use that to index a vector. So if I say x truths, it's going to pull out 1, not 2, and 3. So it's going to pull out 5 and 7. It's going to pull out the 1 and 3 element, and x, of course, is here. So that's kind of some basic vector operations. We can make a matrix using the matrix function. So again, some markdown tricks. If I put these quotation marks or tilde marks from markdown, it will make it appear as code. And so I could say x is a matrix, maybe 1 to 25. Number of rows is 5, and I'm going to put these in by row. So 1 to 25 here is going to give me, let's just first print that out. 1 to 25 is just the numbers 1 to 25, and x, if I pass 1 to 25, it'll give me a matrix of 1, 2, 3, 4, 5, kind of row-wise, because it passed row-wise, but by row is true. I could also create a matrix y. You can use the array function. That's another function you could use, and you pass it the dimensions. So 25 to 49, that's the values I'm going to put in the array, and then I will give it the size of the array. So this is 5 by 5, and I can print it out by typing y. So this is this matrix, and I can matrix multiplication is done with the operator. So the matrix multiplication operator is %*%. Right? Whoops, that should be marked down. And so I could say x times y, multiply them together, and this is the output if I multiply them together. There's lots to cover for in R. Let's just cover some other of the basics. Let's say flow control. Let's make that markdown. And so if A is false, I can say if A, if A, what do I want to do? Print true, else print false. All right. So this prints out false, as we'd think. You can do a for loop, say for I in 1 to 10, print I, print out the numbers 1 to 10. You can do while loops. I is 1, while I is less than or equal to 10. Print I equals I plus 1. And that would be the same kind of thing. There's a lot to R. These are just some of the basic syntax here. So I think it's pretty straightforward. If you've programmed anything like Python before, you should be pretty comfortable with it. I'm going to copy a link here. There is a good tutorial by Dr. Lemus, which can be found here. Oops. And let's see if I can copy this URL here. Oh, copy this, paste this. Okay. Whoops. Let's make that markdown. So there's a tutorial here by Dr. Lemus, which if you've taken 520, you've seen this before, but this is some stuff you're probably familiar with. It has a whole bunch of stuff in R, and this is 87 pages. We're not going to be able to cover it in kind of the 20 minutes here. But this gives you a sense of what Jupyter looks like. I have some links up here for installing R Studio. If you're less comfortable with some of the more advanced fiddling around computers, I would go with R and R Studio. If you want a challenge, you can go with Jupyter, which will give you something like I have here. I will post this notebook on the web page. If you notice here, so this lab1.ipynb is this notebook. I also have a .rmd file. So if I can open up, this is R Studio, and this is a copy of that same file, but in the RMD format, which stands for R Markdown. And it's very similar to Jupyter. There's advantages and disadvantages, but I can do kind of similar things. So here I have my code, I can run it, and it prints the output. I can use R's calculator as I showed, all this good stuff. I can run all my chunks, printing out all my output down here in the console. And this is the exact same notebook, but in R Markdown. And so if you want to use R Studio, this is the preferred format. For homeworks, you can use whatever you want. You can use Python. You can do that any language you want, frankly, to do the analysis. I will be providing some solutions in R. So I've used RStudio in the past. It works pretty well for students. I think there are some advantages to Jupyter. So I'll providing everything both as an R Markdown and as a Jupyter notebook for everyone. In addition, in addition to kind of displaying the results in the editor, you can also render these either as HTML or PDF or Word document. So here, say I could render this as an HTML document. This is going to need me to install other things. You can do the similar things here. If I go in Jupyter Lab and I say export as, let's say, HTML, and it's going to produce this HTML document with my whole code input and output, which is nice. So I'll be providing all our labs this way. Also, for homeworks and projects and stuff, you probably want to output as a PDF. That's probably the easiest to share. So this has been a real quick overview. But the course is not, at the end of the day, about software. Definitely come to office hours if you have questions about any of this, and I can see if I can try and help you. You'll get more comfortable as you see kind of this get used, and as you do some homework problems using this. But I will leave it there for the first lab.